You ever try to fold a roadmap? I'm having trouble with it too, but I think this one you're going to have a lot more fun with. My name's Dave Chalupsky. I'm with the Ethernet Alliance, and we're here at Interop, and we're going to talk about the 2015 Ethernet Roadmap. Well, this is something that we in the Ethernet Alliance put out this year. One of the things we like to do in the Alliance is, take a little history lesson of where Ethernet has been, a little snapshot of what's going on in the industry right now, and then try to use our crystal balls to project where we think Ethernet's going to go in the future. Now, Ethernet Alliance is an alliance membership where many companies who are involved in the Ethernet ecosystem, whether they're suppliers of components or systems or end users, we all try to get together to promote Ethernet and the new technology that's going on there and help get the message out to you. So this little gem here, this Ethernet roadmap, kind of encapsulates what's going on in Ethernet right now. So let's take a look. Unfolding it sometimes is as hard as folding it. All right, you'll notice that like most pieces of paper, this roadmap has two sides. This is no three-sided piece of paper. Now, like any good roadmap, this roadmap actually has a road. And what we see on this roadmap, on this road of the roadmap, is basic speeds and feeds of Ethernet. Ethernet, as we know, is a networking technology originally made for local area networking. How do you connect your mini computer to your printer? Well, its uses have evolved beyond that over the years, let me tell you. So early Ethernet was 10 megabit per second, first standardized in 1983, and over the ensuing decades we went from 10 megabit to 100 megabit to 1 gigabit to 10 gigabit, and then something funny happened on the way to 100 gigabit. We suddenly took a departure from this powers of 10 advancement in the speeds, and we developed both 40 and 100 gigabit at the same time. Now, why would you do that? Well, in the early days of networking, things happened to work out just so that doing everything 10 times faster worked out well with the technology and the needs at the time. But what we see happening in the environment today is technology advances are happening at weird different paces, and that the way people use networks is really diverging into a bunch of different use cases. That's on the second side, we'll get to that. So what happened with our basic speeds and feeds is when we did 100 gigabit, we decided to also include 40 gigabit. And at the time what we were thinking was server networking. I've got some servers in my data center in my server room, and they're just using 1 gig today, just starting to use 10 gig today. And if the next jump in speed is to go from 10 to 100, that sounds like a pretty big bite to chew. Could be kind of expensive to make that big leap from 10 to 100. Now this is a discussion we were having back in about 2007. So we included 40 as being the gentler way to get to a higher speed, and also standardized 100 at the same time for different applications where the need for speed was there, just go do it. Now, if we keep going down the map, project we have in development right now is 400 gigabits per second. This is in standardization today. But if we look back here, we see some other bubbles going along. We see these 2.5, 5 gig, 25 gig. These are projects going on right now to standardize specific implementations of Ethernet that really map specific use cases well. So 25 gig Ethernet is one that's been in development for about a year now. And really what that's doing is taking advantage of the electrical physical layer signaling that was first developed for 100 gig. So one of our 100 gig flavors of Ethernet we have implements 100 gigabits as 4 independent lanes operating together. Each lane is 25 gigabits per second, and we can bundle those 4 up, so logically it's 100 gig. Well, it turns out that 25 gig lane is such a sweet spot on the electrical technology that it kind of makes sense to use 25 gig as its own port speed in its own right. And that's why we've got 25 gig Ethernet going on right now, and there's certain markets where that really helps. Again, we've got 2.5 and 5 gig, and then trying to look out in the future, we see just by looking at the technology where it's going, what the underlying electrical capability is, I think that probably 50 gig, a single lane of 50 gigabits per second might be the next thing that we want to standardize. These are called, estimated or proposed. There's no current standards activity, but this is the direction we see the technology going. That I could take a 50 gig per second single lane interface. It'd be a nice, very cost effective. What can I do on one lane, as we call it? But if I also want to bundle that one lane up and use them 4 at a time, 50 gig also can be packaged up to make 200 gig. So that's how we get these, what are you folks doing now with all these odd speeds? Well, as we get a little closer to the horizon, things might be going 800, 1 tera, maybe 1.6 terabit. Or a lot of variables between here and there, so we're not sure how we're going to solve that problem yet. Another thing that's a lot of fun, and when I say fun, I mean fun, about this roadmap is that we've got some roadmaps on individual types of physical interfaces, like your multimode fiber, it's used for shorter reaches. Say today our new multimode fiber specs do about 100 meters on multimode fiber. Single mode fiber, this is where you're using your longer hauls, where you might have to go 10 kilometers, 40 kilometers. You're most likely to use single mode fiber. Now, twin-ax cabling, this is a copper pair of cabling. It's a very high quality cable, and it allows me to use a fairly simple chip, simple PHY device electronics at the ends and use some low-cost cabling. Our trade-off there is we can only go a few meters, so it depends on what speed we're going. Maybe it's a 5-meter, 7-meter reach. Our twisted pairs, this is really the Ethernet that's been with us and is probably most well known by most human beings on the planet. Anyone who's had a PC in the last 10 or 20 years had an Ethernet port on it that was an RJ45 plug. Depending on when you got that PC, it might have been running 100 megabit, 1 gigabit, and maybe a few coming out with 10 gigabit now. But what's a cool thing about our twisted pair, or what we call the base T flavors of Ethernet, is that they're all using a compatible connector, and they all use 4-pair cabling. So when we develop a new one, a new higher speed base T, the cabling that you need to run that, you can also run lower speeds. So if you've got the cabling to do 10G base T, 10 gigabit Ethernet today, you can also use that to run your gigabit Ethernet or your 100 megabit Ethernet on that same cabling. And also on the twisted pair roadmap, we're getting so crazy on twisted pairs that today from 10 gigabits, we're departing in 2 directions. We're going faster. We're developing both 25 and 40 gigabits on base T, twisted pair cabling, and we're also going slower. Why go faster and slower at the same time, you may ask? Well, we're doing 2.5 and 5, and they've got different uses. And that's a good point to flip over the map. And what else do you find here on the backside of the Ethernet roadmap is we're trying to lay out here some of the different environments, the different use cases, end user environments where Ethernet is used. So probably, the longest running, most popular still would be the enterprise and the campus, corporate offices. This is where, corporate LANs, attaching your PC to a network so you could use the printer and share a drive. This is where Ethernet's been since the 80s and 90s. And it's still there today. But there's also residential and consumer stuff, hooking up many of your consumer electronics not only support Wi-Fi, but they also support a wired Ethernet. And then there's service providers. This is how you get stuff to your home. So your service providers are delivering telephony or cable TV kind of media content. Boom, boom, boom. Let's go back over here to this other quadrant. A real, newsworthy thing that's been going on in just the last few years is the notion of a hyperscale data center. One giant building that may house hundreds of thousands of servers and all the necessary storage and compute that goes along with it. And you know the names here. When you get on the internet, all those cool services you're using, it's all that stuff is stored and powered by someone who's running a hyperscale gigantic data center. This is a very different business. When you've got some companies that deploy million square foot data centers with hundreds and hundreds of thousands of computers, they've got a different way of operating than the thousands and thousands and thousands of corporations out there who just, trying to do their day-to-day work. You're the insurance company, you're the news guy, you're the whatever. You've got in your office, you're still using Ethernet, but a lot of the way human beings get on the network these days is going more and more away from the wires into the wireless. So, My PC still has a wired Ethernet jack, but I also have Wi-Fi 802.11. But the more you use the wireless, the more we still need wires, because the wireless only goes so far. Your wireless signal goes to a device that's called a wireless access point. And then upstream from that, there's a wired connection, a wired Ethernet connection that gets your data up into your corporate network. And today that's typically a 1000 base T connection running on, Cat 5e cabling. But what's changing is that the wireless is going faster. So Wi-Fi is not standing still. Wireless speeds are going faster and faster, which means the need for the Ethernet backhaul up into the LAN is increasing. So there's a lot of products on the market today that are using 802.11 AC, and they need about a gigabit or more than a gigabit of upstream bandwidth. Well, in the wired world, we're kind of stuck. I've got 1 gig, and then it's a big jump to 10 gig. And one of the deployment challenges from going to 1 gig and 10 gig is that you can't really get 100 meters of reach on these older categories of cabling, your 5e and your 6 cabling. If you want 100 meters at 10 gig, you need the Cat 6a or better cabling. Sort of, reality check here. We're talking about, in many cases, office spaces that are existing buildings, have been around for 10 or 20 years, and that cabling was installed 10 or 20 years ago. It's probably Cat 5e or Cat 6 cabling. In the past 10 years, there's been about 70 billion meters, that's billion with a B, 70 billion meters of Cat 5e and Cat 6 cabling shipped worldwide. Man, that's a lot of cabling. And today, we've got a 1 gigabit speed limit on that cabling. But what we want to do is apply our latest and greatest technology to get more than 1 gig, and we picked 2.5 and 5 gig as kind of the convenient implementation points that also match what the applications need. So that's why, back on our Twisted Pair roadmap, we're looking at 2.5 and 5 gig, so we can get more data bandwidth out of this installed base of Cat 5e, Cat 6 cabling, with the leading reason being wireless access points. Now, once that technology is out there, who knows, people can use it for all kinds of things. Maybe you now have more storage out there, or you want to get your workstation jacked up to the next best speed. Who knows where it's going to go? And I think that's about all I got on the Ethernet roadmap. This is Dave Chalupsky with the Ethernet Alliance. Have a great day.